Welcome to our lesson on trapezoids. So today our objective is that we will be able to use the properties of a trapezoid and the properties of an isosceles triangle to find the missing lengths and show a figure is a trapezoid. And this goes for also knowing the difference between a general trapezoid and an isosceles trapezoid. So our definitions today, a trapezoid is a quadrilateral with exactly one pair of parallel sides. And those parallel sides are called bases. And the non-parallel sides are called legs. So if I look at my trapezoid over here to the left, we have our parallel base and the other base. And then our legs are the ones that are not parallel. So if the legs of your trapezoid are congruent, that's when we call it an isosceles trapezoid. And its base angles then are also congruent. So this is similar to an isosceles triangle. So if these bases, AB and CD, if these legs are congruent, then the angles opposite them are also congruent. So this would be a base. So these base angles are congruent. And this is also a base. And these base angles are congruent. So let's use these properties and look at some examples. So example 1, we have a trapezoid here, and this is an isosceles trapezoid because it has the legs marked congruent. And so we know that on an isosceles trapezoid, our base angles are congruent. So if A is 55, the angle over at D is also 55. But how do I find B and C? Well, B and C, remember these are parallel, and this would be a transversal. So if I have this, that means that this green highlighted angle and this green highlighted angle are consecutive angles. Just like what we've been doing with parallelograms, trapezoids the same thing. Consecutive angles are supplementary. So if I call BX, supplementary means I can add them to equal 180. So angle B then is 125. And angle C is the same thing. Remember, we have isosceles trapezoid, so this is also 125. All right, number 2. I'm going to pause for a moment and see if you guys can figure out number 2. Watch out because this trapezoid is kind of turned sideways from what you may be used to. So angle C and angle D are base angles together. And angle B and angle A are also base angles. So take a moment, hit pause, and try out this problem. See if you can find measures of B, C, and D. Alrighty, so when I start this problem, 110 is the same measure as angle B because those are my congruent base angles. So angle B is also 110 degrees. To find angles C and D, we're going to use supplementary angles. Because again, these are parallel lines. And then we have this transversal that comes across, so I have consecutive interior angles here. Right here and right here. And we know that consecutive interior angles are supplementary. So 110 plus C equals 180. So angle C is going to equal 70 degrees. Which means angle D is also 70 because this is an isosceles trapezoid, which means my base angles are congruent. Alright, so here's a little bit of information. And a trapezoid can be an isosceles trapezoid if you know it has a pair of congruent base angles or if it has congruent diagonals. So in this example, use a diagram to determine if this is an isosceles trapezoid. EG is congruent to FH. EG, FH. Those are the diagonals which would fall underneath this criteria. If it has congruent diagonals, it's an isosceles trapezoid. So we can say, yes, this is an isosceles because we have congruent diagonals. Question 4, HEF. So HEF goes like this. So it'd be this angle here is 70 degrees. And then it also says FGH. FGH. This angle here is 110. So does this make it an isosceles trapezoid? Not quite based on how we show, but we can find more information about this. We can't say that we have congruent base angles because we don't know that it's an isosceles trapezoid. But our supplementary consecutive angles will always hold true. Okay. So if I draw out our parallel lines here, and I draw the transversal, angle F and angle G, those are always going to be consecutive angles, so they will always be supplementary. So angle F plus angle G is always going to equal 180. So that means F equals 70. Well, now I have a pair of congruent base angles, and congruent base angles falls under this criteria. So yes, this is an isosceles trapezoid because we have congruent base angles. So let's go on to mid-segments or medians. So on trapezoids, we kind of tend to use mid-segments and medians interchangeably on a trapezoid. So this connects the two midpoints of the legs of a trapezoid. Okay, so that means that point M here is a midpoint and point N is a midpoint. So it's dividing everything perfectly in half. Okay. So to find the length of that midsegment, you're averaging the bases, which means you're going to go base plus base over 2, because you're averaging, right? To average means to add them and divide will equal your midsegment. Okay. So if I look at number 5 here, we want to find the length of the midsegment here because we know both of these bases. So we want to find this here, x. To do that, we're going to add the two bases. So I have a base of 12. Remember, your bases are your parallel sides, so a base of 12 and a base of 28. And divide by 2. 12 plus 28 is 40. Divide by 2. 20 inches, okay, would equal my midsegment. On question number 6, this is asking us to find the other base because it gives us the length of the midsegment. So we could use the formula. We'll call our missing base x. So add the two bases, 14 plus x, and divide by 2 equals our midsegment. And then to solve this, we're going to multiply by 2 on each side to get rid of that denominator. And then subtract 14. So that would be the missing base. Another thing you can do with any of these problems is you can look for patterns. So if I was looking at number 6 here, from 14 to 8, I subtract 6. So I'm going to do the exact same thing because it has to be right in the middle. So 8 minus 6 would be 2. You could look for that pattern. You're going to have the same thing over here, 12 to 28. If I go all the way down here, okay, from 12 to 28, I'm adding 16. So to get halfway, this is plus 8 and plus 8 again. So you can do it in that way too. But generally speaking, if you're looking for a mid-segment like problem 5, the formula is going to actually be really easy to use. If you're looking for a base, the formula is easy to use, but you may be faster at finding the pattern. So either way is going to be okay. All right, our last problem here. Figure RSTU is a trapezoid, and M is the midpoint of RU, and N is the midpoint of ST. So I'm going to go ahead and draw a trapezoid here. So I've got the point M is the midpoint of RU. Then I have ST, and this is going to be N. If RS is 3x plus 5, MN is 30, and UT is 9x minus 5. Find the value of x. All we're doing is the same thing we just did, but now we have algebraic expressions. So we're going to take our bases and add them. So here's one base, and add it to my other base, and then divide by 2. And that will equal our mid-segment 30. So just add your bases, divide by 2. Now we can solve. So multiply each side by 2 to get rid of that denominator. I'm going to combine my like terms on the left. 9x and 3x is 12x. Negative 5 and positive 5 is 0. So 12x equals 60. And then divide by 12. X equals 5. And that'd be it. So let's go ahead and just kind of outline and highlight a few things we need to remember. So for a trapezoid, okay, we have parallel bases. We need to remember that. We also have consecutive angles supplementary. But remember, consecutive angles is not the same as base angles. Okay, so just keep that in mind. Consecutive angles are supplementary, but the base angles are not supplementary. An isosceles trapezoid this has congruent base angles. And the last thing we talked about was about mid-segments. So a mid-segment is the average of the bases. What that means is you take your two bases, base plus base, divide by 2, and that equals your midsegment. So just keep that in mind. Okay? Trapezoids, parallel bases, consecutive angles are supplementary, and then you have that unique isosceles trapezoid with your congruent base angles. And then finally, we have that midsegment, which is the average of our bases. And that's all for our lesson today.